How do we get molten steel into a form that we can use, and what is the best way of doing this? In this module, we will try to answer these questions by looking at casting. Following steel making, casting is required to solidify the molten steel ready for shaping or forming into a suitable profile. The three main ways of doing this are sand casting, continuous casting, and ingot casting. Sand casting. Sand casting is a process for making a part by pouring molten metal into a mold, having a cavity of the desired shape, and then allowing it to solidify. In sand casting, sand mixed with water and suitable binders is the molding material. The molding material is packed around a pattern often made of wood. This pattern is slightly larger than the finished part due to the contraction of the metal on solidification and cooling. When the pattern is removed from the molding material, a cavity having the same shape as the pattern remains. The sand must be packed or rammed to the correct degree to avoid air or water vapor being trapped in the molten metal, causing unsoundness. The cavity is usually created in 2 or more sections that are then fitted together to create a mold. The mold will have 1 or multiple holes in which to pour the molten metal. There will be channels to direct the molten metal, and there will also be a reservoir next to the cavity, so that when the molten metal in the cavity solidifies and consequently shrinks, any voids will be immediately filled with more molten metal from this reservoir. Metal of the desired composition is heated well above its melting point in order to ensure good fluidity. If this is not done, the molten metal may solidify in the mold and consequently be unable to completely fill up. Many casting grades of steel have higher levels of silicon, as this helps to increase the fluidity of the molten metal. After the metal has solidified, the finished casting can be shaken or knocked out of the mold, which can only be used once. The advantages of sand castings include low cost, high flexibility. Virtually any size casting can be produced, and it is a simple, expedient way to make a wide range of products. Continuous casting. Usually, continuous casting uses feedstock from the basic oxygen steel process. A ladle of steel is teamed or poured through a gas-tight refractory nozzle into a tun dish with special weirs and dams to aid in the removal of impurities. This tun dish is a reservoir, and it feeds the steel through further gas-tight nozzles into a number of water-cooled copper molds. The cooling is controlled, and only the outer skin of the steel is solidified. The molds are oscillated to ensure that the solidifying shell does not stick and break. Flux is also added to aid lubrication. The steel shell grows as it is drawn down through a curved arrangement of support rolls and water sprays. It then emerges horizontally as solid steel strands and is cut to length with automatic gas burners. Depending on the size, these solid strands are called billets, blooms, or slabs. The billet, blooms, and slabs are normally processed through a rolling mill where the cast structure is refined. Initial setup of a continuous caster is expensive, but it is a very efficient process, has an excellent throughput, and has yield benefits over other types of casting. Ingot casting. Ingot casting is primarily used with the electric arc furnace, and as with continuous casting, it is an intermediate process to solidify steel to enable further shaping, primarily in a forge or rolling mill. It is a process where molten steel is poured into a cast iron ingot mold, often cylindrical in shape. The finished ingots can weigh anything from a few kilos to hundreds of tons. The main ways of casting these ingots are either uphill teaming or vacuum casting. Ingots that are uphill teamed use a ladle either directly or in a teaming car that is positioned over a feeder system to enable the ingots to be filled from the bottom of the mold. The ladle is positioned over a funnel called a trumpet. It is opened and the metal stream established. The pouring rate is controlled throughout this teaming process. Powders which have an exothermic reaction are often added to the top of the ingot following teaming to generate heat to aid in the feeding of the ingot, minimizing voids called pipe. Insulating material is also added to aid in this. For ingots that are vacuum cast, the mold is placed in a vacuum tank and an intermediate ladle is positioned on top. The ladle that is on the vacuum tank is filled with molten metal and the tank's pressure is pumped down to create a vacuum. Pouring of the ingot is started and the intermediate ladle is fed with additional molten metal if required. The ingot is filled, the pressure vented, and the same exothermic and insulating powders are added to reduce voids in the ingot called pipe. Although these powders are added, some porosity and vacancies will form within the material due to shrinkage and gases liberated from the operation. A large feeding pipe defect is cut from the ingot, but most porosity in the ingot is acceptable since it will disappear through further processing in the rolling mills or forge. In both continuous and ingot casting, the metal solidifies from the outside, progressing towards the center, and thus the ingot's grain structure develops as columnar and points in the direction of solidification. This grain structure development is typical of cast materials. Hot rolling or forging will break up the cast structure and form a smaller, more uniform wrought grain structure. Ingot casting is better suited to one-offs and small batches. It is also able to produce large ingots easily and is the least complicated of the casting techniques. So in summary, the advantages of sand casting include low cost, high flexibility, virtually any size casting can be produced, and it is a simple, expedient way to make a wide range of products. Ingot casting is used primarily with the electric arc furnace and is best suited for one-offs and small batches. It is also able to produce large ingots easily and is the least complicated of the casting techniques. Continuous cast and ingot cast materials are further worked in a rolling mill or forge to refine the structure, whereas sand castings are not.